Okay, here we go. Number 1. So you're always trying to get the x by itself, right? And so the first thing that you should try and do, which some people were forgetting to do, is subtract 8 from both sides. Because we're trying to get the x by itself, and there's no reason for us to bring in any craziness with logs and natural logs and things like that until we have to deal with the exponent. Okay? We're still not ready to do that. What do I have to do first? Get rid of the negatives. As we've talked about before, you cannot take the log of a negative number. So if I took the log of both sides right now, I would have issues. So I'm going to essentially divide both sides by -1 to get rid of the negative. So now I have done everything that I possibly can. Now I have to log both sides. So log 3 to the x equals log 9. Bring the x in front. Divide both sides by log 3. And x equals what, Elliot? 2. 2. Yeah.
Do we have to do all that log stuff, or can we just figure out what?
You do not have to do all that log stuff. You can look right here and say 3 to what power equals 9? 2. And then you're done. Lane?
We have to show our work like that.
Yes, because I want to make sure you're not copying off the L.
I wasn't over there yesterday.
Well, you know the test steps. I don't care what you do on this.
I don't even know how to write it out like that.
Well, then you better pay attention.
I won't even sit my empty Let me do this next one.
Okay, now you can do the same thing with this. You can just remember the definition of a log.
4.
Right, this is saying 3 to what power equals 81.
Can we do it the long way?
And then once you get to here, you can do the long way. You can do the log of both sides again, if you want to. So that gives you x log 3 equals log 81. Divide by log 3, and you find out that x equals 4. Okay? Which again, like Ashley said for the other one, you can just say from the very beginning, 3 to the what power equals 81. Do a little guess and check, and get x equals 4. Either way, you get the same number. Okay? There's another way you can do it.
No.
Okay.
I just did it 3 to the 4.
Yeah. All right, and then number 3. Same kind of dealio, but now we have 2 separate log functions. So what do I have to do before I mess with those? Combine them, and I'm going to do that by recognizing that subtraction is the same as division. So that comes out to look like that. Some of you are incorrectly writing log x divided by log 3. Okay? And it works out, and I'm not too super concerned about it, because then when you tend both sides, like we're about to do, you cancel both logs, so you end up with the same answer. But just understand that when we're combining these, we're combining them to a single logarithmic function. Okay? All right, so now I base 10 both sides. The log and the 10 cancel, leaves me x over 3. 10 squared is 100. 3 times 100 is 300. Then you're good. All right? So that is solving log equations in a nutshell. No, it's not. This is solving log equations in a nutshell. What am I doing in this?
I know that movie.
Where did they find this unusual log?
Stop it.
Okay, number 4 asks you to figure out an interest thing. Remember that we have 2 different equations for finding interest, okay? If this were compounded annually, then I would write the equation 2,000 times 1 plus 0.04 to the 8. Do you remember that?
No.
Okay? That's if it's compounded annually.
Why is the 1
The 1 is there because you get your original money plus 4%.
Because it's
Okay? Right, because it's growth. If I did not have the 1 there, what I would figure out is just the interest that I would get, but I want to know the interest and the original, okay?
Continuously.
But this one says continuously, and so continuously uses this formula right here. Whoops, there's an A there. And so if I'm going to do that, in this case, A is the initial amount that I'm investing, which is 2,000. Or 2 grand, as they say on the mean streets of Montana. And this is going to be to the 4% as a decimal is 0.04. And then the time is 8 years. And you just put that into the calculator.
Is that 1.04?
Do you put the?
It is not 1.04, no. What? Yeah, that would be lots of money. I wish
I
we could do
asked
that.
you what the thing after the P
So
was.
that, my answer was 2,000.
The thing after the P is an equal sign.
Aldrich, where's the E?
No, then after the equal.
It's an A, that's the amount.
That's what I put, and she changed it.
You can't round up.
Yeah.
I did 16. I told you
Second,
I did.
Is it what?
The island of
16,000? That seems like a lot, yeah. 2,700.
25 cents.
25 cents.
Yeah.
Okay, it's possible, Mac, the mistake you made is that both of these are in the exponent.
Did you close your
Okay,
parentheses?
so you have to go 2,000 times e to the 0.04 times 8 and then close the parentheses. Yes,
Does it matter if it ramps up or down?
yes.
You don't run out of money, right?
Oh, you want to make it 24 cents?
No,
This makes
26.
all-
26.
Oh, 26. No, that doesn't
A
matter.
quarter to half, I told you.
You never round up.
It doesn't matter.
Yeah, because the way.
I didn't know
I
what.
rounded up.
Mac, here's what I got going. 2,000. Second, E
Oh, that's right.
0.04
It's
times.
insured.
Yeah.
Okay. All right. Now we're taking a look at the graphs. So if I start with -2 to the x plus 1, I have 2 things that I have to deal with here. The negative does what to the graph?
Flip over
It
X.
flips it over the x-axis.
Flip
Wow, you're smart.
over x-axis, and the plus 1
Moves it
up
up.
1.
And is there not a stretch?
No, there's not a stretch. For there to be a stretch, there'd have to be a number in front of the 2.
Why is it
2 is
flipped
the
over the
base.
negative?
Because of the negative, yeah. Okay, so the next one, 3 to the x minus 4. So now the
Right.
minus 4 is in the exponent, so instead of moving it down 4, it moves it the opposite direction, which is just to the right 4. Yep. And then number 7, 5 to the x plus 1 minus 2. This goes to the left 1 because of this.
And down
then
2.
Down 2 because of that. Okay?
I'm just so good at this.
All right, now we are evaluating logs. So all of these, you're thinking this number to what power equals that number? And so that is
3.
3. This one might, you might think that's a little tricky, but 1/2 to what power is 1/4? 2, because 1 squared is 1, 2 squared is 4, so 1/2 squared is 1/4, so my answer is 2. Number 10.
Could you explain that one again? Yeah. I know.
1/2. If I'm going to do 1/2 to the second power, I just do the top number squared and the bottom number squared. So 1 squared is 1, 2 squared is 4, so that's why.
Okay, because I was wondering like
Well, we'll get there in a minute.
11.
All right, 3 to the what power is 729? 6, and that's just a guess and check. You just keep doing powers right until you get the answer that you're looking for. What are you talking about? Number 11? Yes. Okay, number 11, things start to get tricky because if you start putting 9 to different powers, you're never going to get 1/3. So you know something weird is going on, okay? So the first thing I'm going to do is I'm going to go, well, 9 to the what power is 3. So I'm going to ignore the fraction part and try to figure that part out first.
1/2.
Right, the square root of 9 is 3, and the square root as an exponent is 1/2. So I know 9 to the 1/2 is 3. So that's half the battle. Then if I want this to be a fraction, I just need to make it a negative exponent, because when I do negative exponents, that means I have to go 1 over the number. So my answer is negative 1/2. Yeah, so 2 pieces there. One is that it's a fraction because we're taking a root, and the other is that it's negative because my answer is a fraction.
Cool.
So the same thing is true for number 12. If I'm going to go 1/4 to a power and get 16, the first thing that jumps out at me is that 4 squared is 16, so 2 is close. But what do I have to do to the 2 to make it a fraction? Make it a negative. So it's going to be negative 2. All right? And then 13 is the most exciting one of all.
Yeah, we need to go slow.
Yeah, so if I'm looking at 8, I might go, okay, well, 8 to the what power is 256? Doesn't work. So then I have to recognize if I go 8 to the 1/3, I get 2. Now can I raise 2 to a power and get 256? Yeah, what power?
5.
Is it 5?
I don't get it.
What? 8? Okay. So if I go 8 to the 1/3, that gives me 2, right? And 2 to the 8 is 256. So that means that 8 to the 8/3 is 256. Jefferson? What? I'm sorry, I didn't hear you because. Whoa, huh? I have no idea.
Don't you need a negative?
Yeah, you need a negative. I want to make sure that everybody understands the 8/3 before we move on to negative. Okay, so then that gives us 256. But now since we went 1 over 256, that means it's going to be negative 8/3. Okay?
Still don't get it. Negative 8/3, all right. We'll take it.
Negative
There
8/3.
is, Katie.
You could have
That's
just
just the answer of the power.
8 to the x equals 256, and now x log 8 equals log 1 over 256, and then divide by log 8.
That's what I was
There you go.
Okay, I want to see that.
Oh, just keep going together.
So you're doing this, right? He's saying, he's going like this. He's going, what this question is asking is 8 to the what power equals 1 over 256, right? Okay, well, how do we get the x out of the exponent? Log both sides. So make it log 8 to the x equals log of 1 over 256.
Wait, don't you put the x in front of the
Yeah.
Then we're going to put the x in front of the log. Okay, and then to
Divide
solve
by
for
log
x,
8.
you divide by log 8. And if you do that coincidentally, no, it's not a coincidence, you will also get negative 8/3. Okay, which is negative 2.6 repeated. Okay,
Or you can use the other option.
It is.
or you could do this right from the beginning because Elliot recognizes that as the change of base formula that
Okay, I
you
think
are
that's
asked to
better.
use on number 20. Which in fact, you could solve all 6 of those problems that way without doing an ounce of thinking, which is why I was trying to speak over Elliot and Jefferson when they were. No, we don't want to get in trouble. It's really confusing. Really confusing.
So you made us do it the hard way.
All right, number 14. Write each equation in logarithmic form. So now we're going backwards. We're saying if 7 to the 3rd equals 343, that means log base 7 of 343 equals 3.
Why isn't it 3 log 7 equals log 3?
Because it's not.
Oh, I get it, because you're thinking of the bottom one to the power.
Right, this number to this power equals this number right here. That's the definition of the
That's the
logarithmic.
answer right there?
That's the answer right
Wait,
there.
don't move, don't move.
Well, I don't like the 15 on its own.
I don't want
Oh, it's so easy though.
Yeah, it's not.
15, you're going to take and rewrite that as
All to the
We get to use these
2/3.
log base 2/3
27
is
eighths.
27/8 equals negative 3, because we have mostly been working the other way, but what this means is 2/3 to the negative 3rd power equals 27 over 8.
Okay, so 16 is log base 2
So far, so good.
equals 0.
Log base 2 of what?
0 point.
Of 0.0625 equals negative 4.
I do so.
Because you said log base 2 and then you said equals.
No, I didn't.
Okay.
I
Jenna?
did 15. I do it.
That's the little power there. Okay? Yeah. Full day, last full day of the month, last full day of the quarter. Join the club.
Well, that's right there. Base 2.
I have a question.
Wait, so that's what-
Go back. So how come your power for 14 and 16 aren't the same?
Because they're different questions.
That was not. Or, no, you definitely just did it. No, you did it wrong.
Wait, what?
No, you did it wrong.
It always equals the power.
Well, no,
So,
she tricked me. She tricked me.
okay. Good job, Emily. Keep tricking me.
So mad.
All right, so now we are combining these again as a single log. So we're only going to write the word log once in our answer, final answer. So the first thing I'm going to do is deal with this number right here. That becomes a power. So I'm going to rewrite that as log 1 to the 3rd. But 1 to the 3rd is obviously 1. And then subtraction is the same as division. So my final answer is log 2 over 1, which I could also write as plain old log 2. The reason why that works out is because, what's the base right here? 10. And so this is asking 10 to the what power is 1.
10.
0. And so this essentially cancels, and that's why you're left with just plain.
So why isn't it?
Yeah. I'm just trying to explain a little deeper level.
Stop.
Because you,
Never mind. Don't you make a division?
yeah, you made a division. Subtraction is division, and 2 divided by 1 is 2.
Why didn't you do that first?
Wait,
Because I needed to get rid of this number in front before I did that.
Yeah. So how do you do it for the time?
I turned it into an exponent.
Yeah, I did that, but
And then 1 to the third is just 1.
oh, then you did.
Okay? Okay, 18.
okay, we'll get over that.
18, same deal, but we are using variables, thank you. Subtraction is the same as division. I am writing this as a single log expression, so it is not log A divided by log AB. It is log A over AB. Okay? But then do the math. What can I do with the A's? Cancel?
So it's log of B.
That's log of 1 over B.
You have to put 1 over B.
Yeah,
Because B is under the fraction.
Yeah.
Pass out of place.
there's still something on top of that.
Okay, cool.
Okay, we do clean or we
I need to get up. I just want to settle.
Okay, and then number 19.
Literally because I hate to know.
Two different ways. Well, let's distribute the 1/3 first. Let's do it the easy way. Okay? So this is going to start out being 1/3 log base 4 of x plus 1/3 log base 4 of z.
And then put the 1/3.
I know you just didn't make what you do.
I just distributed the 1/3 to both terms.
Oh.
Then it'll be
And then the 1/3 becomes an exponent for both of them. So log base 4 of x to the 1/3 plus log base 4 of z to the 1/3.
thing combined because
They both have the same base, so addition becomes
Multiplication.
So it's log base 4 of x to the 1/3 z to the 1/3. Which you could write as the cube root of both of them, or you could parentheses both to the 1/3.
So
And
that's my
since the
answer?
1/3, yeah, that's my final answer. Since the 1/3 goes to both the x and to the z, both of these variables have to be raised to the 1/3 power.
Yeah, I know.
All right, and then number 20.
Let's still be good.
This is what Elliot was talking about, that we could have done with 8 through 13 to solve them. If I use the change of base formula, it is log of the big number divided by log of the little number. And then you could figure out what that is. The question doesn't actually ask you to figure that out, it just asks you to rewrite it.
How do you know how to do that? Whenever you
We learned it.
like just
Yeah, I don't know.
I could really go back and find it up if you wanted.
could you?
Just what?
What are we doing today?
I'll try to do it.
Okay.
Tomorrow?